2.5 million stone blocks, each one weighing as much as 2 cars, stacked 20 stories high with tolerances tighter than modern skyscrapers, built by a civilization with copper tools and no wheels. For 4,000 years, the Great Pyramid has been called impossible. Archaeologists can't explain it. Engineers can't replicate it. And conspiracy theorists claim aliens must have done it. But what if I told you that modern engineering has finally cracked the code? That the truth is even more impressive than the myths, and that what we're about to reveal will change everything you thought you knew about ancient Egypt? I'm about to show you exactly how the pyramids were actually built, and I'm bringing receipts. Before we solve this mystery, we need to understand exactly what we're dealing with. Because the numbers behind the Great Pyramid aren't just impressive, they're statistically impossible by conventional theories. The Great Pyramid of Khufu was the tallest structure on Earth for 3,800 years. It stands 146 meters tall. Its base covers 13 acres, and it contains approximately 2.3 million stone blocks. But here's where it gets crazy. According to Egyptologists, this pyramid was built in roughly 20 years. That's the reign of Pharaoh Khufu, based on historical records and archaeological evidence. 20 years sounds like a long time until you do the math. 2.3 million blocks divided by 20 years equals 115,000 blocks per year. Divide that by 365 days and you get 315 blocks per day. Now, account for the fact that ancient Egyptians couldn't work during the annual Nile flood, which lasted about 4 months. That reduces your working year to roughly 240 days. So now, we're at 480 blocks per day. But it gets even more insane. The ancient Egyptians didn't work at night. They had no electric lights. So we're talking about a 10-hour workday, maximum. That gives us 48 blocks per hour, or 1 block every 90 seconds. Think about that. For 20 years straight, workers had to quarry, transport, lift, and position one massive stone block every 90 seconds. 10 hours a day, 240 days a year, for 2 decades. And we're not talking about pebbles. The average block weighs 2.5 tons. The granite blocks in the King's Chamber weigh up to 80 tons. That's 160,000 pounds. The weight of a fully loaded semi-truck. Modern construction cranes can lift that much weight, sure, but they need steel cables, hydraulic systems, and diesel engines. The ancient Egyptians had copper tools, wooden sledges, and linen rope. So how the hell did they do it? Before we answer that question, we need to look at where these blocks came from. Because the logistics of the pyramid aren't just about lifting stones, they're about moving millions of tons of rock across the desert. Most people assume the pyramid stones came from far away, making the construction even more mysterious. But here's the first myth we're going to bust. The majority of blocks didn't travel far at all. Modern geological analysis has confirmed that approximately 90% of the Great Pyramid's limestone blocks came from local quarries less than 500 meters from the construction site. The ancient Egyptians literally built the pyramid next to their stone supply. But they didn't just chip away at random. Recent archaeological work has revealed an incredibly sophisticated quarrying system. When you examine the quarry sites around Giza, you can still see the tool marks in the rock. And these marks tell us exactly how the Egyptians extracted stone blocks. First, they would identify natural fractures in the limestone. Then, using copper chisels and dolerite pounders, they would carve channels around the desired block. These channels were typically 10 centimeters wide and ran along all 4 sides of the block. Here's where it gets ingenious. Once the channels were cut, workers would hammer wooden wedges into small holes along the base of the block. Then they would soak these wedges with water. As the wood absorbed water, it expanded with tremendous force, enough to crack the limestone along a controlled line. This technique, called plug and feather, is still used by stoneworkers today. It's simple, effective, and requires no advanced technology. Just knowledge of materials and patience. Experiments by modern stonemasons have shown that a team of skilled workers using ancient methods can extract a 2.5-ton limestone block in about 3 to 4 days. That includes all the cutting, wedging, and final separation. Now, do that math against our earlier numbers. If one team can produce a block every 4 days, you'd need roughly 20 teams working simultaneously to hit the 480 blocks per day target. That's about 100 to 120 workers just in the quarries. But here's where the mystery deepens. While most blocks came from local limestone quarries, the granite blocks in the King's Chamber came from Aswan, 800 kilometers up the Nile. These aren't ordinary blocks. Some weigh 80 tons, and granite is significantly harder than limestone. You can't cut it with copper chisels. So how did the ancient Egyptians quarry granite? The answer lies in one of Egypt's most fascinating archaeological sites, the unfinished obelisk. This massive granite monolith, still attached to the bedrock in an ancient Aswan quarry, shows us exactly how the Egyptians worked with granite. They used dolerite pounders, spherical stones weighing 5 to 10 kilograms, to literally pound the granite into submission. It's not cutting, it's controlled pulverization. Teams of workers would rhythmically strike the granite surface thousands of times, gradually crushing it away. It's brutally hard work, but experimental archaeology has proven it works. A team at the Aswan Quarry demonstration site in the 1990s successfully carved a channel in granite using only dolerite pounders, matching the ancient tool marks exactly. Once quarried, these granite blocks faced an 800-kilometer journey. And here's another engineering marvel. The ancient Egyptians timed their granite deliveries with the Nile's flood season. During the annual inundation, the Nile would rise dramatically, and the Egyptians built temporary canals that brought water right to the base of the Giza plateau. Granite blocks, loaded onto wooden barges, could be floated from Aswan to Giza using the river's natural current. It wasn't fast. The journey probably took weeks, but it was effective. And it explains how they moved materials that would be challenging even with modern trucks. So now we've solved the quarrying mystery. The Egyptians had the stones, and they had a way to move them to the construction site. But we still haven't answered the big question. How do they lift millions of tons of rock into a structure 20 stories tall? That's where things get really interesting. For over 2,000 years, historians have debated how the pyramids were built. The ancient Greek historian Herodotus, writing in the 5th century BCE, already 2,000 years after the pyramids were constructed, suggested that machines made of wood were used to lift the stones from one level to another. But he was guessing. He had no evidence. In modern times, theories have ranged from straight ramps to spiral ramps, from internal ramps to lever systems, from water-based elevators to, yes, alien intervention. Until recently, none of these theories fully worked. They all had fatal flaws. Take the straight ramp theory, probably the most popular. The idea is simple. Build a ramp from ground level to the top of the pyramid, gradually raising it as the pyramid grows. Workers drag blocks up the ramp and position them. Sounds logical, but the math kills it. To reach the pyramid's summit at a safe 7-degree incline, the maximum for heavy loads on ancient sledges, a straight ramp would need to be over 1.5 kilometers long. That ramp would contain more material than the pyramid itself. It would be a construction project bigger than the pyramid, and then you'd have to dismantle it completely. Plus, there's zero archaeological evidence of such a massive ramp ever existing at Giza. Okay, what about a spiral ramp that wraps around the pyramid's exterior? More efficient, right? Shorter total length. Again, sounds good. But there's a problem. As the pyramid narrows toward the top, there's less and less perimeter to work with. Eventually, the ramp would become too steep or too narrow to be functional. And again, no archaeological evidence of exterior spiral ramps at Giza. Some researchers have proposed sophisticated lever systems using wooden beams and counterweights to lift stones, level by level. Herodotus mentioned this, and it's mechanically possible. But here's the issue. It would be incredibly slow. Remember, we need to place one block every 90 seconds to meet the 20-year timeline. A lever system might work for the final, lightest stones near the pyramid's peak, but for the bulk of construction, it doesn't scale. So, what's the answer? What method explains the evidence, matches the timeline, and could actually work with ancient technology? The solution came from an unexpected place. Inside the pyramid itself. In 2017, French architect Jean-Pierre Houdin published a groundbreaking theory that sent shockwaves through Egyptology. He proposed that the Egyptians didn't use external ramps for most of the construction. They used internal ramps. Houdin's theory suggests that after the first 43 meters of the pyramid were built using external ramps, the Egyptians constructed a spiral ramp inside the pyramid itself, hidden within the structure's mass. This internal ramp would tunnel through the pyramid's interior, spiraling upward at a comfortable 7 to 8 degree incline. Workers would drag blocks through this tunnel, emerging at progressively higher levels of construction. The ramp would be integrated into the pyramid's structure and wouldn't need to be dismantled afterward. It would simply be sealed up as part of the finished monument. The genius of this system is efficiency. An internal ramp uses far less material than an external one. It's protected from weather. It's stable and doesn't need constant rebuilding. And it explains why we find no evidence of massive external ramps at Giza. They never existed at the scale we imagined. But Houdin didn't just theorize this. He found evidence. In 2023, a team of scientists used advanced microgravimetry, a technique that measures minute variations in gravitational fields to scan the interior of the Great Pyramid. And they found exactly what Houdan predicted. Density anomalies consistent with internal voids arranged in a spiral pattern. They discovered a corridor-like structure spiraling upward through the pyramid's mass, with slightly lower density than the surrounding solid stone. This is exactly what you'd expect if there were a hollow ramp built into the structure. Now, this doesn't mean the mystery is completely solved. The scans aren't detailed enough to confirm every aspect of Houdan's theory. But they provide the strongest evidence yet that something is inside the pyramid's walls. Something that looks a hell of a lot like an internal ramp system. But here's the next question. Even with ramps, internal or external, how did workers actually move these massive blocks? Because dragging 2.5 tons of stone up an incline isn't easy, even with a ramp. This is where ancient Egyptian engineering gets truly brilliant. In 1995, a team of engineers and archaeologists conducted a famous experiment. They took a replica limestone block weighing 2.5 tons, placed it on a wooden sledge, and attempted to drag it across sand. It didn't move. The sledge just dug into the sand. Then they tried something the ancient Egyptians depicted in tomb paintings. They poured water on the sand in front of the sledge. Suddenly, the coefficient of friction dropped by 50%. The wet sand became firm and smooth, and the sledge glided across it. A team of 12 men could now pull the 2.5-ton block with relative ease. And we know the Egyptians did this because we have wall paintings showing workers pouring water in front of sledges during construction projects. It's right there in their art. They literally showed us how they did it. With this method, researchers calculated that a team of 20 to 30 workers could transport a standard block from quarry to pyramid in about half a day scale, that up to our required 480 blocks per day, and you'd need about 10 to 12,000 workers in transportation and positioning roles. But we're still missing something. We've explained the quarrying, we've explained the transport, we've explained the ramps. But there's one aspect of pyramid construction that's more impressive than all of those combined: the precision. When you stand at the base of the Great Pyramid and examine the joints between blocks, you see something that shouldn't be possible with ancient technology. The gaps between stones are so tight that you can't fit a piece of paper between them. We're talking about tolerances of 0.5 millimeter or less, across blocks that weigh tons, on a structure that covers 13 acres and rises over 100 meters tall. Modern engineers struggle to explain this level of precision, because achieving it requires 3 things: accurate measurement tools, sophisticated leveling techniques, and an understanding of large-scale geometry that historians didn't think existed in the ancient world. But it did exist, and we can prove it. Let's start with measurement. The ancient Egyptians used a unit called the royal cubit, about 52 centimeters, and they built physical cubit rods carved from wood or stone with subdivisions marked to the millimeter. We have surviving examples of these cubit rods, and they're shockingly precise. Some show subdivisions down to 1.8 millimeters, less than the thickness of a penny. The Egyptians understood precision measurement, and they standardized it across their entire kingdom. But here's what's truly remarkable. The Great Pyramid's base is almost perfectly level. Modern laser surveys have shown that the difference in height between the highest and lowest points of the Great Pyramid's base platform is only 2.1 centimeters. Across a base that's 230 meters on each side. That's a precision of better than 0.01%. On a platform built 4,500 years ago by hand on irregular bedrock. How? The answer is water. The ancient Egyptians invented one of the most brilliant leveling tools in history, the water level. Here's how it works. You carve channels in the bedrock in a grid pattern. Then you fill those channels with water. Water always finds its own level due to gravity. It's physics. So the surface of the water in those channels gives you a perfectly level reference plane across the entire site. Now, workers can measure from the water's surface to the top of the bedrock at any point. Wherever the bedrock is too high, they carve it down. Wherever it's too low, they build it up with stone. Eventually, your entire platform reaches the exact same height above the water level across the whole 13-acre site. It's genius. It's simple. It requires no advanced technology, just an understanding of basic physics and a lot of careful work. But leveling the base is only part of the precision equation. The pyramid also had to be accurately aligned to the cardinal directions, and the Great Pyramid's alignment is frighteningly accurate. The pyramid's sides are aligned to true north, south, east, and west, with an error of only 3 arc minutes. That's 1/20th of a degree. For comparison, most modern buildings are considered well aligned if they're within 1 degree. So how did the Egyptians achieve 3 arc minutes of accuracy without a compass? They used the stars. Specifically, they used a technique called the Indian circle method, or stellar alignment. By observing the rising and setting points of stars on a carefully constructed circular wall, and bisecting the angle between those points, ancient astronomers could determine true north with remarkable precision. We know the Egyptians did this because we have texts describing astronomical observations and architectural tools designed for stellar sightings. The pyramid texts even reference specific stars used in alignment ceremonies. This wasn't luck. This wasn't aliens helping out. This was sophisticated engineering based on careful observation and mathematical understanding. And the precision doesn't stop there. The Great Pyramid's corners form almost perfect 90-degree angles. The deviation is less than 2 arc minutes. That's 1/30th of a degree. The Egyptians achieved this using a tool called the set square, and by applying the Pythagorean theorem. Yes, the same one you learned in school. Except they were using it 1,000 years before Pythagoras was born. We have surviving mathematical papyri that show Egyptian engineers working with right triangles and understanding the 3-4-5 ratio for creating perfect right angles. They might not have written it as an algebraic formula, but they understood the principle and applied it flawlessly. All of this precision culminated in the pyramid's outer casing. Originally, the Great Pyramid was covered in brilliant white Tura limestone, polished to a mirror finish. These casing stones weren't just decorative. They were precision engineered to fit together with those impossible half-millimeter joints. Most of these casing stones were stripped away in medieval times to build Cairo's mosques and palaces. But a few remain at the pyramid's base, and they show us exactly how precise the original surface was. Each casing stone was cut at an exact angle, 51 degrees, 52 minutes, to create the pyramid's slope. The stones were dressed smooth on 5 sides and fit together so perfectly that the entire structure appeared as a single, seamless surface. Imagine standing in ancient Egypt and seeing this. A perfectly smooth, brilliant white structure rising from the desert. Its angles precise, its edges sharp, its surface gleaming in the sun like a man-made mountain of light. That was the Great Pyramid. Not the weathered, stepped structure we see today, but a geometric marvel of engineering precision. So we've established that the ancient Egyptians had the tools, the techniques, and the knowledge to build the pyramids with incredible precision. But there's still one massive question we haven't fully answered. Who actually did the work? And here's where we need to destroy one of the most persistent myths about the pyramids. For centuries, popular culture has told us that the pyramids were built by slaves. Tens of thousands of enslaved people, whipped and brutalized, forced to drag stones until they died. It's a powerful image. It's been in countless movies, documentaries, and books. And it's completely wrong. In 1990, Egyptian archaeologist Mark Lehner discovered something that changed our understanding of pyramid construction forever. A workers' village at Giza. This wasn't a slave camp. It was a complex settlement with bakeries, breweries, food storage facilities, and living quarters. And the archaeological evidence paints a picture of workers who were well fed, cared for, and, most importantly, paid. Analysis of food remains shows that pyramid workers consumed enormous quantities of meat, primarily beef, mutton, and fish. Studies estimate they ate about 4,000 cattle and 22,000 sheep and goats throughout the pyramid's construction. This isn't slave rations. This is good eating. The kind of diet you provide skilled workers you need to keep healthy and productive. But the most compelling evidence comes from the workers' cemetery discovered near the pyramid complex. When archaeologists examined the skeletal remains, they found something remarkable: evidence of medical care. Some workers had suffered serious injuries, broken bones, back injuries from heavy labor. But these injuries had been set properly and had healed. Some individuals lived for years after their injuries, continuing to work in less physically demanding roles. You don't provide medical care to slaves. You work them to death and replace them. But you do provide medical care to valued workers you want to retain. Even more fascinating, archaeologists found graffiti throughout the pyramid complex, ancient tags left by work crews. These crews had names like Friends of Khufu and Drunkards of Menkaure. They were organized into teams, and there's evidence of friendly competition between crews. Modern analysis of the workers' village suggests a sophisticated organizational structure. At the base were unskilled seasonal laborers, probably farmers who worked on the pyramid during the Nile's flood season when their fields were underwater. These workers would number in the thousands. Above them were skilled craftsmen, stonemasons, carpenters, metal workers, and engineers. These were permanent, professional workers who lived at the site year-round. They were the specialists who ensured the precision and quality of the construction. At the top were administrators, architects, and priests who managed the massive logistics of the project. We have papyrus fragments showing detailed records of food supplies, tool inventories, and work schedules. This was a managed project with documentation and accountability. So how many workers did it actually take? Modern estimates based on the archaeological evidence suggest a permanent workforce of around 10,000 skilled workers, supplemented by up to 20,000 seasonal labourers during peak construction periods. That's 30,000 people maximum, not the hundreds of thousands of slaves that Hollywood would have you believe. And these workers weren't just local. Evidence suggests they came from all over Egypt. The pyramid was a national project, a symbol of Egypt's power and the pharaoh's divine authority. Communities throughout Egypt sent workers, materials, and food as a form of taxation and religious obligation. This is crucial to understanding the pyramids. They weren't just monuments to royal ego. They were religious structures, considered sacred. Working on the pyramid was seen as a religious duty, a way to serve the gods and ensure the pharaoh's successful journey to the afterlife. And workers were compensated. We have evidence of payment in food, beer, and possibly small amounts of copper or precious goods. Workers' families received additional support. In Egyptian society, these jobs were desirable. So the pyramid wasn't built by slaves. It was built by skilled professionals and seasonal labourers, well-fed and organised, working on what they considered a sacred project. But understanding who built the pyramids is only part of the story. Because modern engineers have done something that puts all of this in perspective. They've tried to replicate ancient Egyptian construction methods, and the results are humbling. In 1997, a team of engineers and Egyptologists attempted to build a small pyramid using only ancient Egyptian tools and techniques. The project was called the Nova Pyramid Experiment, and it was meant to answer a simple question. Could modern people, with ancient methods, actually build a pyramid? The answer was yes, but barely. The team successfully quarried, transported, and stacked limestone blocks to create a pyramid about 6 meters tall. They used copper chisels, wooden sledges, and simple ramps. Everything the ancient Egyptians would have had. But it took them 3 weeks to build a structure that was less than 5% the height of the Great Pyramid. And the team consisted of experienced engineers, architects, and skilled labourers with modern nutritional knowledge and safety equipment. Scale this up to the Great Pyramid's dimensions, and you begin to understand the magnitude of what the ancient Egyptians accomplished. They weren't just building a pyramid, they were building the largest stone structure on Earth, with precision that modern technology struggles to match, using tools we consider primitive. It's humbling for modern engineers. Several structural engineers who've studied the pyramids have gone on record saying they don't think we could build an exact replica of the Great Pyramid today. Not because we lack the technical ability, but because the project would be economically impossible. One estimate suggested that building the Great Pyramid with modern methods would cost between $5 and $10 billion and take at least 10 years, even with cranes, trucks, and power tools. The precision requirements alone would require computer-controlled cutting and positioning systems. And yet, the ancient Egyptians did it with copper saws and wooden rollers. In 2000, a Japanese research team attempted another replication experiment. They tried to move a single 25-ton block, much smaller than the 80-ton granite blocks in the king's chamber, using ancient methods. They failed. The block was too heavy for their wooden sledges and rope systems. They eventually had to use a small crane to position it. British Egyptologist Dennis Stocks spent years experimentally testing ancient Egyptian stoneworking tools. His conclusion: the Egyptians were far more skilled than we give them credit for their copper tools, when properly manufactured and maintained, could cut limestone efficiently. Their understanding of leverage, friction, and material properties was sophisticated. But here's what's truly astounding. Modern analysis suggests that the ancient Egyptians built the Great Pyramid at a rate of efficiency that exceeds most modern construction projects when adjusted for available technology. They were operating at near optimal efficiency with Bronze Age tools. That's not luck. That's not brute force. That's engineering excellence. Recent computer simulations have modeled different construction scenarios, testing various ramp configurations, workforce sizes, and logistics systems. The simulations that successfully complete the pyramid in 20 years are the ones that assume a highly organized, skilled workforce using sophisticated techniques. In other words, building the pyramids required something we don't usually associate with ancient civilizations: systems engineering. The ability to break down a massive project into manageable tasks, optimize workflows, coordinate thousands of workers, and maintain quality control over decades. This is the kind of project management you see in modern mega projects, like the Channel Tunnel, the Burj Khalifa, or the Hoover Dam. Except, the ancient Egyptians were doing it 4,500 years ago. But there's one more aspect of pyramid construction that's only recently been understood, and it's the key to everything. The ancient Egyptians didn't just have good tools and smart techniques. They had something even more valuable: institutional knowledge. Here's something most people don't realize about the Great Pyramid. It wasn't the first pyramid. It wasn't even close. The first true pyramid was built about 80 years before the Great Pyramid. It was the Step Pyramid of Djoser, designed by the legendary architect Imhotep. Before that, Egyptians had been building massive mastaba tombs for centuries. Between Djoser's Step Pyramid and the Great Pyramid, the Egyptians built at least 7 major pyramids, each one teaching them new lessons about engineering and construction. They had failures. The bent pyramid at Dashur famously changes angle halfway up because the builders realized their initial slope was too steep and the structure was becoming unstable. So they adjusted mid-construction. But they learned from that failure. The very next pyramid they built, the Red Pyramid, used the corrected angle from the start and became the first successful smooth-sided true pyramid. This is the key that everyone misses. The ancient Egyptians had generations of accumulated knowledge. The workers who built the Great Pyramid weren't figuring it out from scratch. They were refining techniques that had been developed over a century of trial and error. This knowledge was passed down through apprenticeship systems. Master masons taught their sons and apprentices. Architect families held positions for generations. The chief architect of the Great Pyramid, Hemiunu, came from a family of high officials and engineers. There's evidence of formal training programs for scribes, architects, and engineers in ancient Egypt. These weren't casual arrangements. These were structured educational systems designed to preserve and transmit technical knowledge. We have surviving mathematical problems that were clearly teaching exercises, problems about calculating ramp volumes, stone quantities, and construction angles. The Rind mathematical papyrus includes problems specifically related to pyramid construction geometry. The ancient Egyptians were systematically teaching engineering mathematics. This institutional knowledge is similar to the guild systems of medieval Europe, where master craftsmen passed down the secrets of cathedral construction through generations of builders. Those cathedrals took centuries to build, but each generation added to the collective knowledge. The Egyptians did the same thing, except they did it faster and with better results. And here's the tragic part. This knowledge was eventually lost. After the Old Kingdom collapsed around 2100 BCE, Egypt's centralized government and its supporting institutions fell apart. The engineering schools closed. The master-apprentice chains were broken. When later pharaohs tried to build pyramids, they failed. Middle Kingdom pyramids from 1,000 years after the Great Pyramid are crude by comparison, made with mud brick cores that have since collapsed. The techniques had been forgotten. This proves something crucial. The pyramid building capability wasn't magic or alien technology. It was learned knowledge that could be lost when institutions failed. Only now, 4,000 years later, are we rediscovering these techniques through experimental archaeology and modern engineering analysis. We're reverse engineering the ancient Egyptians' institutional knowledge. And what we're finding is that they were brilliant. So let's bring this all together, because we now have the complete picture of how the pyramids were actually built. Here's how it happened. This is the engineering truth behind the greatest construction project in ancient history. Step 1. Site preparation. Engineers selected a bedrock plateau at Giza and used water leveling techniques to create a perfectly flat platform covering 13 acres. This took months of careful surveying and stonework. Step 2. Quarry operations began. Teams of specialized stoneworkers extracted limestone blocks from nearby quarries using copper chisels and dolerite pounders. They worked in shifts, producing hundreds of blocks per day. Simultaneously, granite blocks were quarried at Aswan and transported 800 kilometers down the Nile during flood season. Step 3. A sophisticated logistics system moved blocks from quarries to the construction site. Wooden sledges pulled over water-dampened sand made transportation efficient. During the Nile's flood season, temporary canals brought water close to the pyramid, allowing waterborne transport right to the base. Step 4. The first 43 meters of the pyramid were built using external ramps. These ramps were probably made from mud brick and limestone chips, materials that could be easily sourced and later removed or repurposed. Step 5. Once the base was established, workers constructed an internal spiral ramp within the pyramid's mass. This ramp allowed continued upward transport of materials without requiring massive external ramps. The ramp was eventually sealed within the finished structure. Step 6. Each block was carefully positioned using wooden levers, copper crowbars, and precise measurements from standardized cubit rods. teams of masons would spend hours fitting each stone, ensuring those impossibly tight joints. Quality control was maintained by master craftsmen who checked alignment and level constantly. Step 7. As the pyramid neared completion, the fine Tura limestone casing stones were installed from the top down. These precision-cut stones were polished to a mirror finish, creating the pyramid's smooth, brilliant surface. Step 8. The pyramidion, the capstone, was placed at the summit. This final piece, possibly covered in gold or electrum, completed the structure. The work crews sealed the internal ramps and removed the external construction infrastructure. Total time, approximately 20 years. Total workforce, 10,000 permanent skilled workers, plus up to 20,000 seasonal laborers. Total cost, incalculable, but representing a significant portion of Egypt's national resources during Khufu's reign. The result? A geometric marvel that dominated Earth's skyline for 38 centuries. No aliens, no lost super technology, no magic. Just brilliant engineering, sophisticated organization, and the accumulated knowledge of a civilization at its peak. The ancient Egyptians built the pyramids with copper tools, wooden sledges, and human muscle. But more importantly, they built them with intelligence, precision, and institutional knowledge that took generations to develop. That's the truth, and it's far more impressive than any conspiracy theory. The Great Pyramid stands as proof that ancient people weren't primitive. They weren't less intelligent than us. They simply had different tools and different priorities. Modern engineers look at the pyramids with awe, not because they're impossible, but because they represent human capability pushed to its absolute limit with available technology. The ancient Egyptians took Bronze Age resources and created something that rivals our greatest modern achievements. And if we've been this wrong about the pyramids, what else have we misunderstood about the ancient world? Because the pyramids aren't the only engineering marvel ancient Egypt left behind. There are temples cut from solid rock, obelisks weighing hundreds of tons transported across continents, astronomical alignments that shouldn't be possible with ancient tools. If you want to dive deeper into these mysteries, subscribe to Pharaoh's Legacy. We're uncovering the truth behind Egypt's greatest enigmas, one engineering marvel at a time. Hit that subscribe button, ring the notification bell. Because next time, we're investigating something even more controversial. The hidden chambers beneath the Sphinx. And what we've found is going to blow your mind.